All right, so today is March 25th. We're looking at Zach's blood, first time ever. Okay, so we're going to start over here. Now, when we take a look at the blood, the number one cause of all pain and disease is a lack of oxygen. The red cells transport the oxygen, but they have to be round to be able to transport oxygen. So if we look at your cell walls, they are nice and round. Very, very good. Okay? Come on. All right. But we'll see that there are a few cells. See how they're getting that pointy end? Those are called dacrocytes, okay? And what that indicates, we call that protein linkage. So remember when we got your blood sample and that blood was a little bit runny, okay? You do have an issue digesting proteins, okay? And even like the stickiness here too is indicating that protein metabolism is a problem for you. You're an O blood type. Your body lives on protein.
Yeah.
So we got to help you with this. Okay. So that's not a problem. I mean, but this is, you know, you know, it's not something that you would normally find out in a lab kind of a thing. Okay. The other thing is too, is you see these cells where the light is shining through the center of the sample?
Yeah.
These are called target cells. Okay. Now, have you ever been told you were anemic?
A girl at work told me I look anemic.
Okay, all right. I'm going to turn the light back on because I'm going to show you one of the fastest ways. All right, give me your hand. All right, and straighten it out. Okay, yeah, you are. Here, take a look. See how red those lines are? And see how white yours are?
Well, if I stretch, this is still... Oh.
Yeah, see the difference in
Yours
the
is
color?
supposed to be like that?
Yes.
Oh.
Okay.
Whoa, okay.
All right. So, yeah, you do have... But think about it, Zach, because our protein is where the iron and the B vitamins are.
Oh.
Okay? And you're not breaking it down really well.
Okay.
So that's where... See, you don't want to take an iron supplement. Okay? That would be the worst thing for you. You're a man, all right?
Yeah. Oh.
Iron is one of the top mineral that will feed cancer cells.
Oh.
Okay? So for women that are having periods and losing blood every month, taking an iron supplement isn't a problem. Okay, they can get rid of excess. You can't. All right, so that's why we have to make sure that you're able to break down your foods
properly.
Efficiently.
Yeah, efficiently.
Exactly,
Yeah.
so you can get those nutrients out of your foods. Okay?
Yeah.
All right, and then...
Whoa, that one looks...
Yeah, it's got a little bit of an irregular shape. We'll always see a few irregularly shaped, but see how
these
sticky.
pointed ones.
Yeah, but see that's what's happening.
That one's a
Right. See, so what's happening is it's a physics concept called zeta potential. So what that means is that these cells, the fats that are on the membrane, are lined up so that the negative charge is on the outside, okay?
Yeah.
If you take a negative magnet and a negative magnet, they won't stick, right? It has to be plus to minus for them to stick. But what's happening is two things. Number one, if your minerals are out of balance, that's going to change the charges on the walls. And then they'll start to get sticky. The other thing too, you had the beer yesterday, okay? And who knows what else was on your board list that you may have had the past few days.
Yeah.
I mean, it's like, the challenge is food sensitivities can take up to 4 days to give you a symptom.
Oh.
So you can have pizza Saturday night and then have a raging headache Monday morning. Okay, so we don't correlate, this is what I ate, this is how I feel, right?
Yeah.
So that's where it's like you start paying attention. Like for me, it's like 48 hours is when I can feel it. Okay, so now you got to find out for you.
Yeah.
Your blood is saying, 12 hours, okay? I mean, because you can see, and that's what happens. They start to get sticky like this, and then they start to stick with each other, all right? And then they start to become chains. Well, here's the problem. Okay, like I said, number one cause of all pain and disease is a lack of oxygen. You make beautiful cells, all right? Now, we do have quite a few iron missing, okay?
Oh, okay.
Well, it's the iron that the oxygen attaches to. Okay, so if you don't have iron, then the cell can't carry oxygen, and that's his job.
And is that what those cells are? Oxygen deprived?
Well, their iron is decreased in these cells, yes.
Oh, okay.
Okay. So the iron is missing in those cells, so they can't transport oxygen. The other issue is too, you know how our blood vessels start out really, really big, the arteries are really big, okay?
Yeah.
And then they get smaller, smaller, smaller. The smallest part of the blood vessel is called a capillary, okay? The capillary is where everything happens, okay? Because think about it. We have oxygen on the red cells, we have nutrients, we have hormones in the plasma, this is where all the invisible work goes on, okay? So we got all this stuff going in here, but it's in the blood, now it's got to get into the tissues, right? Into the body.
Okay, yeah.
Well, when the blood vessels are really thick, nothing can pass through.
Mm-hmm.
So the capillary is only 1 cell thick.
Whoa.
It's the largest end to end, it says it's like 30,000 miles in the body.
Whoa.
Yeah. Okay. All right. So what happens though is the capillaries is a little bit smaller than the size of a red cell. So they literally have to shimmy through those capillaries.
Whoa.
Okay? But when they're sticking like this,
they can't.
Exactly. Very good. Okay? So this is where your vegetables come in. Okay? Fruit's still a sugar. Okay? And papaya's got great enzymes in them. They really do, digestive enzymes. Great for the stomach. Okay? But you're better off having a little bit more vegetable in your diet, okay? Because the vegetables have calcium and magnesium, which are the minerals that will help balance this back out again and make them unsticky. The enzymes in the vegetables and the fruit too will help them get unsticky, right? And then doing foods that are not on the avoid list will also make them unsticky, okay? So here's your white cell right here, okay? Yeah. And the crazy thing is, the red cells, normally, they don't move on their own, but we have these little guys floating around in the background here. Well, the fascinating thing is nobody can tell you what they are.
Really?
They're found in all living things. They can't find any.
Are those alive?
Yep, they can't find
they
any.
They look like they're alive.
Yep, they can't find any DNA. There's no
find
protein.
DNA?
They call it Brownian movement because it's obviously made up of elements. Europe calls them the seeds of life. Okay? Now it was fascinating.
They're good for sure. They're not like.
Yeah, no, well, but they're in all living things. Okay, so I did a lecture one time.
Wait, what are those called?
They're called Protits, Protits, or microzymas, or I mean, it depends on who you study as to what they're called. Because conventional medicine doesn't pay attention to them. Okay, because they don't know what it is, so they don't care about them.
Yeah.
All right. But the thing is like one time I did a lecture for a raw foods group, so I took organic lettuce and I smashed it up and I put it in the microscope. I had 1 billion of these guys doing the happy dance all over the sample. I took a piece of lettuce off of a Subway sandwich, so now that's radiated and grown with chemicals and stuff, right? And there's only 4 in the whole sample. So like I said, the Europe calls them the seeds of life. Life supports life.
Oh, okay.
So food is dead. There's no life in it. So where are you going to get energy from? Okay?
Right, okay. Oh,
so now we take a look at your white cell here, all right? And they're like that Roomba vacuum cleaner. So the black areas are called nuclei. 2 to 4 is normal, okay? And then we could see the cytoplasm on the inside is moving. And then see how he's changing his shape? It's like he sends a membrane out, and then he follows behind.
Oh, and then they're going to fill in that little membrane that he sent it.
Well, they're all talking to each other. Yeah, that's how it moves. Yeah, it sends a membrane and the rest of the cell follows behind. Like that amoeba thing, you know?
So it's cleaning?
Yep, it's like the Roomba vacuum cleaner. As it moves along, it picks up garbage, it cleans off the cell walls. Everybody's talking to each other right now. They're like, whoa, what's going on? We're not moving. It's getting kind of cold. Right? Yeah.
But like this is still like, it's not in my body, so but it's still alive.
Yeah.
Okay.
Yeah, these cells live for about 6 hours outside the body.
Whoa.
Yeah. But see what he's doing? See how he sends that membrane out and then the rest of the cell follows behind. That's how he moves. So he can squeeze between the cells because if there's an infection, he has to get into the tissues. Right now he's in the blood. So he's got to be able to get into tissues if there's an infection.
Can do that?
Yeah. So it can squeeze between the cells. It can thin itself out. Every cell in your body has this thin layer of fluid between it. so it can squeeze and go out of the bloodstream and into the tissues.
Whoa! You can't zoom in even further on the
No,
white. Okay.
no, that's
That'd be insane. I mean, I wonder what like look at all that movement. Like, so what?
Yeah, I'm going to move around to see if I can find a better shot. See, my challenge is, I'm going to tell you very honestly, your sample is really, really stuck together. Okay?
Whoa.
See, I mean, if we take a look at it. Now, this right here is actual food that you've not digested.
In my blood? Whoa.
Yeah. That's like the plaquing, the cholesterol, that kind of stuff. Right there. And
it's
see,
a white
it's
blood
garbage. And look at that. There's a white cell on there cleaning it up.
Oh, that's a big piece for it to clean.
That's like plaquing.
Oh my God.
So we clean out one of your little capillaries. Yeah. But look at that guy.
Wow, that's going to take him forever to do. Well.
Yeah. Right?
Wow.
Yeah. Pretty cool, huh?
Yeah.
I mean, what's nice is to see that it did recognize that there was a challenge. You know, like it's
like if there was no white blood cell on there.
Well, it's fine. I mean, because we're just taking it out of the body, so who knows how fast. But it's nice to see that. Yeah. Now, this is a different kind of a white cell.
Yeah.
So these are the ones we want to see the most of. All right, and these are the next ones. Those are your lymphocytes. So your T cell, B cell, NK cells. That's these cells. So they clean up viruses and cancer cells. All right.
Wow.
So you always have some cells of all of them all of the time. Okay, so if you get exposed to a virus, then this guy activates the cells and says, "Okay, wake up." Okay.
Whoa. So people who have cancer, could you give them more of those cells, or do you have to make the body make more of those?
You know what? It's the key is it's like that's one of those great big question marks in medicine. It's like, you know, it bothers me where. It's like the lymph nodes are where the lymphocytes go to school, okay? And the lymph is responsible for removing heavy metals and cancer cells from the body, okay? Yeah. But when they do cancer surgery, they always pull a lymph node out and they say, oh, it's got cancer in there. I'm like, well, isn't it just doing its job then? You know, it's just like they think that it means that it's spreading. Yeah. Well, but you don't have the same cancer in one site that you have in another site. The breast cancer is totally different than a lung cancer, right? If it's spread, it should theoretically be the same cancer, right? Yeah. So it's one of those great big question marks, you know, it's one of those things where I can't understand it, you know, but the nice thing is like I said, the ratio for you, they're all within normal limits. You got a good number of them.
Okay, yeah.
Okay. So 24 to 40.
What are those cells called again?
Lymphocytes.
Oh, okay. They're lymphocytes.
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 Yeah. So CYTE in Latin means cell.
Oh.
Okay. And lymph, it's, you know, like I said, they go to the lymph to get, you know.
Oh, yeah. Well, why are those so...
It's just the way the lighting is hitting it. See, because what's happening is because your sample is so thick, it's like the light's hitting this in different angles all over the place, okay? So we need to try to find a spot that's a little bit more open so we can see things a little bit more clearly. But this is the important thing, though, because it's like that's why you're here, right? Because it's like it's understanding, okay, you had the beer yesterday, and you look to see just how clumpy, right? Those are those lectins in that food that create that stickiness.
Wow.
Okay? Yeah.
Oh, these like chains?
Yeah, that's called rouleau. So, see, so we go from that pointy end, okay, the protein linkage, then they start to stick together, and then they get the charge increases, then they become chains like this, and then it turns into an aggregate. So this is worse than this.
Wow. Okay.
So, yeah. So basically what this tells me is that you've got gut issues going on, Zach. Okay. I don't know if you're aware of it.
No.
Okay.
Wow.
Yeah.
Oh my God.
Yeah. And then what's happening here, we can see these lines in the background there?
Yeah.
Well, remember what we said, where does the blood go after digestion? What's the first organ that gets the blood?
The kidney, or the liver.
The liver, exactly. Okay? So what's happening now, these lines here, they're called spicules, okay? This is liver stress. So because digestion is having a challenge, the liver is also stressed out too, okay? And over time, years down the road, these things settle in your joints and leads to arthritis. Okay, so arthritis.
Are those crystal? Are those crystal? Like,
they're like fibrins. Yeah, you know, they're
acid. Not
yeah,
acid
they're
crystals.
just.
Whoa, so they're all over.
Yeah.
They're like fiber. Oh.
Yeah, that just tells me there's a lot of inflammation. Okay. And it just, you know, once you start working on that gut, and then there's some more plaquing over here. All right. But yeah, like I said, this is. You know, and somewhere we gotta find a nice open spot here for you. Now we're on the edge here. So are you a big vegetable eater or not?
At lunch, I've been eating salads like the last 2 weeks.
Okay.
But and probably not as much as I juice sometimes, but I have the capabilities to be, and I'm ready to be. I just need to know.
Yeah. Okay.
That it's right.
And see how different this white cell is from this one. See how this one's red.
Yeah.
These are blue.
Yeah.
So these are the ones we want to see the most of. Okay. Those are those neutrophils. Okay. That we've been looking at. This is the allergy cell. That's that eosinophil.
Oh.
So eosin means red.
Oh.
Okay. And the histamine is inside these cells. Okay, so that's basically, so that's why I said yours right now
are a little bit higher.
Yeah, exactly. Where'd you go? There you are. There he is. You see how bright white he is?
Yeah. Wait, is that the one that you said red?
Yeah, it's red, from the different lighting. Yeah. But you see what they do in the laboratory is they have different colored dyes. Okay, so the eosin dye is what this guy picks up.
Oh.
So when they stain the sample, these would be red in a sample. The other guys would be like a bluish, purplish color, and he would be red. That's how they know, oh, he's elevated in eosinophils or whatever. Okay, so and then there's another lymphocyte down in there too. Okay. But you see, the nice thing is, though, I mean, the walls themselves...
The gut problem thing is interesting. Last night, I think it was the scalar thing that was telling me my gut was hurting all night, all night, and I didn't know why, and it was because it was telling me probably beforehand this.
Yeah, and that you had the beer too.
Yeah,
the beer is wheat.
Yeah, but I don't normally. I mean, it's last 2 weeks I've been off, or last week I've been off beer, but before that I've been I drink beer all the time.
See, sweetheart, this is what happens. Okay, so it's your body needs 21 days of a change to make a change. Okay, so it's that's what people are well, I tried to diet for 2 weeks, it didn't work. It's you weren't on it long enough. Okay, 21 days, weekends included. Okay, you gotta go 21 days straight. But what happens is when you pull something out of your diet, you're not even aware of what it's doing to you while you're eating it. But then you pulled it out, and then you had some.
Oh, right.
So your body was overload.
Snapped, yeah. Okay, whiplash.
Exactly. It was too much at one time. Okay? So that's where the challenge is. Okay? But we got to help you with us. So,
iron.
Yeah, okay.
Being able to absorb.
Break down the proteins well to get that iron out of it.
Yeah.
Okay? That's also part of that whole digestion issue that we're talking about.
What does anemia eventually do?
You know what it does? It just wipes you out completely.
Oh.
Here's the bottom line.
Like energy?
Exactly. You're just totally exhausted.
Oh.
No matter what you do, you just can't get energy, kind of a thing. And energy is the key. I mean, the number one cause of all pain and disease is a lack of oxygen. Okay? Otto Warburg won the Nobel Prize in 1931 when he proved cancer cannot grow inside cells that are utilizing oxygen efficiently. So oxygenation is the key. It really is. Okay. So you make these beautiful cells, all right. But we got to kind of help these guys out with the iron. Okay. But I think that what it is, it's a matter of making sure that you're breaking your foods down efficiently, so that look at this guy moving. Check that out. See, now what happens when you do excess sugar in a diet, sugar builds a sludge around the white cell, So he stops moving in 30 minutes. So there could be a bacteria right here and he can't do anything.
Oh.
Yeah, and it takes him 5 hours to break the sugar wall down.
Oh, really?
Yeah. Cool.
Yeah.
Yeah, but we just have to,
Wow, look at it. Yeah, a lot of cells don't have iron.
yeah.
Whoa, what's that?
That's a cell that's breaking down, okay?
Oh.
So what happens is the cell membranes are made up of two fats, fatty acids.
That's a red blood
And
cell?
then- yes.
That's like,
Uh-huh.
it's
What's happening
dying,
is
basically?
because they live 120 days.
Oh.
Okay? So, so that's going to be an average of 4 months, all right? So of course some cells are going to be dying when we take a look at it,
Mhm.
all right? And it's not the norm. I mean, this is the first one we've seen out
Yeah,
of how
yeah, yeah,
many,
I'm not-
okay?
yeah.
So what's happening is the fats are literally puckering up,
Oh.
okay? Yeah. So yeah, there's just
Whoa, go back. Or what's that little? Oh.
when they're round like that, sometimes that could be an old bacterial form,
Oh.
that donut shape there.
Or and the little.
Yeah.
Oh. It's
That
just
right there.
yeah.
Yeah.
It's not like a mini red blood cell.
No, it's
Oh.
moving. It's
Yeah,
no, it's moving. So it's some kind of an old bacterial form.
Oh.
Yeah, like I told you, we've got more bugs in us than we've got cells. Just yeah. All right, so we're seeing pretty much the same thing pretty consistently here.
Yeah.
Okay, so what I'm going to do is I'm going to move over because we got 9 minutes left. I didn't realize it, but for some reason it's only taking 30 minutes on this video.
What do you mean? Is it recording?
It's recording,
Oh, okay.
yeah. Okay,
Oh, 9 minutes of footage left?
yeah.
Oh.
But that's fine because this goes a lot faster. Okay, so
Yeah.
what we do, we've got blood that's dried on the sample. All right, we got 6 layers. So it's called the oxidative stress test, and I have officially renamed this test the scab on a slide. All right. Okay. So if we take a look at the platelets, when they get activated, they make this spider web. Okay. And so that's what a live clot looks like. So the spider web gets, the platelet, like Spider-Man, just sends out the web, and then the red cells get caught. The fibrin is made from protein metabolism. So it's the last way we're going to look for protein metabolism, okay? So when we look at your sample, it should be all the black lines should be attached. They should all be connected, okay? If there's any gaps, any white areas on the sample, we look to see where on the sample they're at, okay? And that can indicate stress, underlying stress. Okay. All right, so this is your sample right here. And we can tell, okay, see these pink areas in through here? So you do have some of those black lines, but you see they should all be attached, okay? And so that's where we keep going back to, you have a real big problem digesting proteins.
Whoa, okay.
It's a real big issue for you. Also, this right here, do you have any kind of issues, any teeth issues right now?
Grinding my teeth.
Okay, all right. Any sinus issues, anything like that?
No.
Skin issues?
No.
Outside of just also the skin. Okay. And grinding teeth is usually an issue with your hips are out of balance. Do you see
Really?
a chiropractor at all? Or?
No, but
okay.
I skateboard, so like I'm like probably out of whack. Whoa, that's really interesting.
Yeah.
My hips, yeah, because I'm bow-legged.
Okay. Okay. So that's a calcium issue. All right.
What is?
Bow-legged is usually an issue with calcium.
Well, like it's not just like I can't touch a.
Right. Okay.
I can change that.
Yeah.
Isn't it just I thought it was just a form of my.
No.
Oh.
No.
Whoa.
Yeah. Now, have you ever had any surgery, Zach?
No.
Okay. Alright. So, see, the center is colon, small intestine. Alright? So, we got that dark in the center there, and like we said in the other sample, it's kind of like your gut here could use some help. Alright. Now, did you get antibiotics when you were a baby?
Oh, I don't know.
Okay, all right. What about any kind of an old head trauma? Did you fall off at the changing table? Did mom drop you?
No.
Anything?
I had Lyme disease and was on antibiotics like 4 years ago. Are you looking for? Yeah, antibiotics I've been like taking like probably all the time, like throughout my life, like whenever I get sick or whatever.
Well, the only reason I'm asking is right in here we got this little white area in the center here, and usually white in the center indicates an old antibiotic issue.
Oh.
Okay. So it's kind of like, but that helps understand where these gut issues, like this is out of balance, is what this is saying.
Yeah.
Okay. So it's just a matter, if this is out of balance, it can't do its job efficiently. Okay.
Yeah.
So,
what do you mean an old antibiotic issue? Like, are they stuck in my system?
no, what happened was when the antibiotic came in,